real exam questions. This is question 49 about ultimate limit state. The two expressions in dimensionless units are in region 2A simple bending, only tension reinforcement, and for each equation, prove the equation. When is this equation valid in the region 2A, and what is the physical meaning of it? We first look at the translation equilibrium between the forces, the force in the concrete and the force in the rebars, in the reinforcement. Those must be equal. The force in the rebars is, of course, a cross-section of the rebars times the stress. And the force in the concrete is, because we are in ULS P here, is the filling coefficient times the depth of the neutral axis times, of course, the width of the section and the maximum or the design value of the concrete compressive strength. We will now divide by sigma S1, and we divide x by d and multiply again by d. We do that to convert this into dimensionless units. We divide both sections by db, then we got AS1 divided by BD is the CC FCD divided by sigma S1. Now we can divide it by sigma S1 over FCD. And doing so, then we know that this is a dimensionless unit, and this CC is also a dimensional unit because those two we have moved at the other side of the equation. From this, we find that omega, because this is the mechanical reinforcement ratio, that omega equals to this expression. But when sigma S1 is FYD, so when the steel has yielded, then at that moment, omega will be CC, because we have to multiply this equation by the yield strength of the steel divided by the actual stress in the steel. So if the actual stress is yielding, then this equation is valid. We now look at the rotation equilibrium at the level of the compression reinforcement. So the bending moment is then, of course, equal to the lever arm Z times the force in the reinforcement. We divide both equations by D. Then the force in the reinforcement is a cross-section times the stress. And we can now divide both sides by BD FCD, so by BD FCD. Then we have here this expression and on the other side this expression. So we know that this is equal to the reduced bending moment mu d. And Z over D is, of course, zeta. And what's left is this. And you can see that this here is, of course, the mechanical reinforcement ratio multiplied by the yield stress divided by the yield stress of the steel. So this equation is only valid when the stress in the steel equals the design value of the steel or the yielding of the steel. So what is now the physical meaning of those two equations? The first equation is, of course, the physical meaning is a translation equilibrium between the force in the rebars and the force in the concrete. And the force in the rebars is, of course, the reinforcement ratio. And the force in the concrete is the filling coefficient times the depth of neutral axis. So the physical meaning is the horizontal translation equilibrium between concrete and steel. Second equation, mu d is omega zeta. It's a rotation equilibrium at the level of the compression force of concrete. And The physical meaning is the bending moment or the reduced bending moment is equal to the reinforcement times the lever arm.